everyone, it's Sean. Welcome back to the channel. I've done quite a few Klipsch SW-450s repairs, although not one quite like this. Not a power supply issue, not a no output issue, but a dropout issue. It's a very intermittent issue, one based upon the input voltage and how it's amplified, and also barring at the input voltage, amplitude of the audio coming in is constant, the output dropping out based upon how we amplify internal. Okay, and I'll kind of explain what I mean by that here in a minute. Now, I hardly ever test these amplifiers with a speaker attached. That's probably something that I should change. I should probably hook up a subwoofer. I've got one sitting here out of an old SW-450 that a customer ended up sending me, somebody who didn't want to repair and said that they were just going to buy a replacement. I said, that's cool. I was like, well, I'll buy your old board and speaker if you don't mind shipping it. And this potential customer just ended up shipping it. And I repeatedly asked him if he wanted payment for it. And he was like, nah. So yeah, this actually helps me test a bit, which, brings me kind of fresher content to an old thing, I guess I could say. But I'm rambling. I kind of want to show you what's going on. What I'm going to do is I'm going to take O-scope probe A lead, and I know the signal on my O-scope is going to look a little bit wonky at first. I'll explain it once we're there. So I'm putting one lead of my O-scope on there to my O-scope channel 8 to here. Hold on one second. Hey, my other lead, I'm going to be checking a test point coming off of the volume potentiometer on this side. So the first thing I'm going to do is go ahead and cut on a 80 hertz tone. Actually, let me make sure the volume is somewhat down here. All right, I'll turn on 80 hertz tone input at 500 millivolts, so peak to peak, so 0.5 volts peak to peak, and we can see an amplified output there. Of course, they put one half of the sine wave onto one side of the speaker, the other half of the sine wave onto the other side. I really don't like this kind of design in a Class D amplifier. I wish they would just go ahead and combine both sides of the sine wave prior to the speaker. But you can see we got an amplified output. Okay. Now, as I increase the volume, we'll see the amplitude increase on that output. And then once I get up to a certain point, you see that that sine wave disappears and then it comes back. And while it's coming in and coming out, over on my on the opposite side, looks like my overhead kind of froze up on me. I'll bring that back in. Over on the other side of my bench where my dim bulb tester is at, we can see the light bulb illuminate for a second and attain high current conditions. So that tells me that we've got a failure here. I don't think it's at the preamp side. I think it's at the output side. I think it's the actual amplifier that's going bad in this thing. Here, let's let me see, can I get this into the shot? So if I get my hand underneath here, I'm just going to kind of prop up this amplifier in my hand. Keep in mind, I got some dangerous voltages. I got main AC going into this, so I got to be super careful. Then I come down here on this bottom pin. You can see that input 80 hertz tone, and currently sitting at 2.7 volts peak to peak. Okay. Of course, the output is currently at 18 volts peak to peak. So I'm going to start to increase this while I'm making that measurement. Up, you can see that the input doesn't go out, but the output definitely does. Okay. So I've got to determine what is exactly going on here. Okay. Is it going to be the other side of this potentiometer creating an issue? Is it going to be the amplifier itself? Could there be a bad capacitor on here? I'm not too sure yet, because these are the things I have to explore. Give me 1 second. I want to show you some other things. All right, so I got everything off the speaker, and channel A and B inputs set to each to terminate to one end of the connectors here for the speakers. So y'all can see what I mean by half the audio waveform, one going to each side. Okay. Now I actually have channel B inverted. You can see that there. I don't know why it's stuck there saying shutting down. Hold on 1 second. All right, now you're seeing what I'm seeing. But it's like nothing wants to work today. Overhead camera wants to freeze up, so does that camera over there. I guess we just we're gonna have days like that. But I've got my B channel inverted. They're both set to 10 by. Okay. Now I want to increase the volume again. Previously, when we were just looking at half the wave, you saw the half that sinusoidal waveform increasing and cut out. Without the speaker, we can actually see distortion on that signal right there. And that distortion will actually eventually freeze. The oscilloscope will freeze. It will cut out there. Okay. So as long as we don't go too high, we don't have an issue. Now, I'm not talking about the distortion you have in the center of that waveform. I'm talking about the peaks. What do I mean by that? Well, essentially, I'm not talking about the distortion that's here at the center. Okay, let me turn the volume up again. These things I'm talking about here, that's the audio distortion I'm somewhat worried about. And I'm wondering if that's, once it's presented at the speakers, if that's kind of that clipping or distortion is causing feedback that's causing the amp to shut down, or something else along those lines. I'm not too sure just yet. But anyways, I've got to poke around this amp, try one or two or several things to try to determine what's causing that issue. So this is going to take me a while. This is it's not an always issue. I can get it to always go once the speaker is hooked up. But, this is kind of like an intermittent issue. But yeah, anyways, I'll let you know what I find out when I come back. All right, so I'm going to monitor the 48 volt input when I turn on the audio at that, with the volume knob increased at the point where the audio cuts out, and I imagine it's going to have an impact on that 48 volts. I don't believe it is the power supply per se, but I want to just verify what impact it does have on the 48 volts. Because if it's going to like an overcurrent or like some kind of protection mode, I would imagine it's going to temporarily shunt that 48 volts to ground maybe. And that's the reason why I see the light bulb illuminate for a brief second there. Let me turn on the audio. Give me a second. Yeah, never mind all the noise you're hearing. Yeah, we can see that voltage drops down, cuts out. Now it's coming back on. That all being said, gotta be careful because I got power applied to here. We do have some weird things I am seeing on top of my filter capacitors sitting right here at the front of the power supply. It is possible that these have started to expend gas or whatever. Or maybe this was just in a dirty place. They're both like that though. Some kind of corrosion or something at the top. I'm not too sure. I can tell you that the MOSFETs here, what create the chopping for the switch mode power supply, they do get pretty hot. And of course we have that one resistor back there, and that's the elastic that's pretty burned up, and that resistor gets to about 200 degrees Fahrenheit, which isn't a big of a deal. But when you put that scholastic that's on there and it cooks or bakes and turns brown, that can be bad for components. I know there are some people who would probably argue that, but I think there's enough references out there across the internet to show how it starts to corrode away at the leads on components and starts to tear up the terminal board. So I might go ahead and address those two things, but I think our issue is going to be over here on the amplifier side. Maybe the driver style IC, or maybe the amplifier IC is bad, or maybe we have a capacitor. Some capacitors need to get replaced. I'm not too sure yet. Or even the volume potentiometer. I've seen where volume pots have caused an amplifier to essentially not work because they're super dirty or something's happening in there. But until I start taking this apart and inspecting more, there's nothing really for me to go on. Well, I've got that 1K pot out, and I just kind of want to show you a couple things. So when we're testing a pot, it's kind of outside terminals, either one to the center terminal. When you have a kind of like a sweeper, maybe not sweeper, potentiometer, whatever, rotary potentiometer, whatever you want to call it. Okay. But when we go across here, outer to center, when you're turning the potentiometer one way, it should go down. And then the other way, it should, pretty much increase. And it'll be a linear fashion to that increase, barring if it's a linear potentiometer or a taper potentiometer. This is actually a taper. I'm going to replace it with a linear. It will work just fine. Tapers are typically used in audio circuits because they make the sound like it's ramping up, like that, versus just being a linear increase all the way up. So it's more of an audible thing for the customer who's buying it. But I don't have any on me. A linear pop will work just fine. So you can see when I go from, all right, on one side, come on, don't be jumping around on me. When I put this side of the pot, left side, at maximum, so 1K on that side. When I go to the other side, that side to center pin, let me probably get center pin first. There we go. Then you can see that we're at minimum on the other side. And of course, turning it counterclockwise, it's going to increase. Now, when you're also testing a potentiometer, you need to go from the outside to the outside. Let me get this out of the way for a second. It's too many things in my way. Okay, and when we're going outside to outside, that's measuring the full resistance of the potentiometer. Oh, give me a second. I'll get something to hold this down. Okay. Now that I got a little vise here, it should make life a little bit easier. Yeah, there we go. All right, so see, when I turn the pot now, at no point in time should this value change. It should stay around, 1K. But there is a quasi, kind of like almost a dead spot in this pot. I mean, 0.001. It's no big deal there, but you see that spot right in there? It's ever so subtle, and it's not all the way at the max point. It's kind of from center to upper range where that spot is. Now, maybe cleaning out the pot will get rid of it, but you shouldn't see a change whatsoever from outside to outside as you are turning the basically the sweeper, the arm inside of here that goes around and sweeps around the carbon trace inside. So here goes the 1K pot that I'm going to replace it. And you can see when I go fully counterclockwise, now fully clockwise, there's pretty much no change there. When we go to the center pin, yeah, we can see that linear change from center pin to outside. Plus, switch over here should be at max 1K, and then I go clockwise. We can see it decrease again. So that would explain probably the sinusoidal waveform that when I took those two signals and put them together, why the amplitude would occasionally jump up and down on the waveform. I guess here we go, amplitude jumping up and down. Pretend like this is my AC waveform, that audio wave with my hands. The amplitude would increase and decrease. That could explain that. I still wouldn't cause the cutouts that we're getting in the upper range of the pot, even though that's where that dead spot is at. Although I am kind of wondering if that's the reason for why I had discovered something else as I was looking through here. So, you know, my thought would probably be like a capacitor or something. And by the way, I did replace the problem caps, typically these 100 ohms, occasionally these right in here, forgive my smash finger there. Mostly these 100 microfarad 16 volt caps are problems. Occasionally I've had to replace transistors in there. Occasionally these back capacitors, mostly the 470. These right here do go bad over time. I have a power supply that I still haven't rebuilt in a spare board. But you know, it's a spare board, so I haven't wasted my money on it. So I did replace these caps because these two here from the main supply, these two here, because they are the problem child. And I put in name brand Nichicon capacitors there instead of those off the wall Chinesey, whatever these things are. Anyways, so again, the voltage, not so much the issue from the power supply. Still had the same problem after doing that. But I said, okay, let me check the potentiometer. And yeah, the pot's going to explain a couple things, but still not explain why the audio is coming out, until I stumbled across the output of our STA-567B IC that we have right here. Get a light on it right here. I'm about to get it up underneath the microscope to the microscope to show you something. Okay, so STA-517B, as you see here, is it's called, according to his data sheet, a 60 volt 6 amp quad power half bridge. Yeah, so that explains why the output power amplification, that one half of the analog signals on one side of the wires going to the speaker and the other on the other side. But as you can see here, give you a second if you haven't figured it out already, which one of these sides is not like the other. Yeah, looking, you can see that one of our outputs here, we're missing a capacitor C511. Don't know the value of it. I might have a spare send somewhere, but I assume it'd be the same capacitance value as this one right here, since these cover both channels. And a little burn mark here. And this is pin, let's see, 18, 17, 16, so 15. 14 and 13, I think. Let's see, 18, 17, 16, 15, 14 and 13. 14 and 13 go to this side of the cap. And it looks like potentially pin 15 touches this cap here, which is on the same plane going to the other side. So 13 and 14 and 15 effectively go through this cap, with 14 and 13 being on one side. Let's take a look at that on the data sheet. All right, so looking here at the data sheet, we can easily see that 15 goes to one side of this 1 microfarad cap we have here. 14's on the ground side. 13's on the ground side of that. So that explains why 14 and 13 are tied together at that point. So yeah, the other cap that we're seeing, that would be over on pin 12. That is a, you know, at least according to this diagram for the data sheet for this, that's on 1 microfarad cap. Now, this would be an application circuit. Doesn't necessarily mean that that's the design of the board below me, but so we're going to have to take a spare or something and see if that still comes across. And you can see, look, there goes the speaker there. And again, that explains you got half the sinusoid coming off here and the other half coming off of there. Then the output to here. You actually have a couple more outputs, so you could actually have 2 speakers being driven from this amplifier. But we can see that without that cap, there would be some kind of instability or something based off of what our VCC in is coming here. So that's going to provide a decoupling to ground. So I could see why that would create an issue with these internal MOSFETs or transistors sitting here that are amplifying. So we need to get that cap replaced. I'm going to also replace the potentiometers on it. I think with the age it warrants it. And I don't think the customer is going to be too fussy about that. So what I'm going to do is I'm going to pull a cap off a spare. We'll see if it's actually at 1 microfarad. We'll get it soldered in. Then I'll button it up. We'll come back and test. Well, with my spare capacitor out, I've got my nearly there's measuring the width of it. I mean, it's not super tiny, but it's pretty tiny. I mean, I've got flakes of conformal coating and other nonsense from the power supply on my desk bigger than that component. It's about 2 millimeters across, so maybe this is a 805 size surface mounted device. 1.2 at its width. Yeah, so I would say that's a 0805 SMD. Of course, that 0.2 slop at the end for the length could be because of the solder that's on the side. And with the multimeter and it out of circuit, come on now, come back over the other way. There we go. All right, so yeah, it is a 1 microfarad capacitor. I've got 109, 1.09, 1.08 right here on the multimeter. Okay, I'm going to get it soldered into the other board and you know, this put back together along with the new pots, and we'll give it a test. So I did get the part in, as you can see right there, and then I went around my multimeter in diode mode and did a continuity check of you know, pin to component there, around. That's top capacitor seen right here from pin 15, I think 18, 17, 16, 15, and then 14, 13 on here. You know, and just make sure that pin for pin testing that it matches what's at the bottom as well, and it does. My only really concern is at this point is what caused that capacitor to blow off the board, and that little spark was the cap bad itself, or is there an issue with this amplifier right here? So I think really the only thing we can do right now is finish clean up the board, get it together, and we'll test it out. Okay, I got just about everything set up to start checking this thing out again. I'm going to turn on AC power. Hopefully nothing goes boom. All right, nothing's boomed so far. Good, I've got my oscilloscope attached. 1 probe to each of the outputs. Let me turn on my 80 hertz signal at 0.5 volts peak to peak. Okay, still nothing. And let me increase the, I got everything at minimum right now. I'm going to increase the LFE. Now I'm going to start increasing the amplitude. And for posterity reasons, that's why I want to look at this AC waveform right now. I want to know if it's prettier. Oh no, it still does get a tad bit ugly there. Yes, that might be the amplifier. You see the upper and lower peaks are definitely still distorted. Okay, let me turn it off for a second. I do need to plug in these inputs right here. That's for the speaker level ends, but yeah, let me turn back on. Oh, I was switching to phase, not the on-off switch. There we go. It's like, why isn't this turning on? Yeah. Well, I guess the telltale sign is, and I'm glad I totally forgot the name of the individual. I'll have to look it up in a second. Who sent me the spare board and the speaker? I'm glad I've got that now to test these amps with, because I can't just solely depend on seeing an AC signal, I believe, anymore out at the O-scope. So let me get this powered off. Let me get hooked up to the speaker, and let's see if it does that cutting in and out stuff again. Okay, so I have the speaker attached now. Still got my O-scope hooked up to it as well. But we're going to turn it on, and then I'll turn on my audio. Yeah, and it's still cutting in and out. So that's going to be the amplifier. I'm going to have to get a replacement amplifier on order, and we'll have to go from there. And I've got the part in. You can see that part number right there. Now the plan of attack is to get this board back out, everything disassembled. I'm going to take my soldering iron and across the pins of the IC low melt solder onto the pins. Use plenty of flux as well, and barring if I can block this capacitor over here and not get it too hot, use my hot air station to heat up the board and the IC at the same time, and then once the IC is free from the board, some pliers, needle nose pliers, or something to pick it up off the board, clean it up, and get the new one soldered back in. So I'll go ahead and take care of all that, and then we'll test again. Wish I had good news for you at this point, but I don't. I mean, kind of good news. Okay, let me say replacing this amplifier IC was a good idea. I got it powered up. I can actually, at the volume knob, significantly greater range, can increase it, and without that clipping and cutting out occurring. Okay, at a much more significant setting, which tells me that as far as the amplifier circuitry within the IC, that efficiency had gone down. Kind of makes sense given we had a blown arc off the board capacitor, so there would be issues with that IC. But as I turn up the HFE or LFE, my low pass filter, this potentiometer sitting right here, which is basically termed as a digital encoder. Anyway, it's not getting into that. The termination points on this do feed into basically our DSP, our digital signal processor, or whatever this IC is here. And once it is turned up, clipping does occur, and we still cut out. So I've gone around and rechecked the caps and the resistors down here to see if they're good. So now I'm going to try to replace this IC, and we'll see what happens once I've done that. For the sake of posterity, and because I like to give you part numbers, you can see right here the Mauser part number right off the package, and it's titled an 8-channel DDX digital audio processor. Okay, audio amplifier, audio processor. So it is very possible that whatever caused the condition with ruining our previous IC, that this one also has an issue as well. So yeah, that's what I'm gonna do. I'm gonna get this one removed. Same process as before. I'm gonna put some low melt solder on all the pins with my soldering iron. Then I'm gonna turn up my reflow station to get some hot air on it, lift it off the board once it's free in order to not break any traces. I'm gonna do all this work underneath my microscope so I can see it better, and then we'll solder on the new pin and test out, which for you will be mere seconds. For me will probably be quite a bit more time. All right, let me get to this. All right, so I've got the that DDX digital audio amplifier installed. We're going to turn on a tone. I've just got this going to my SIGGEN and O-scope for right now. This is on. Yeah, and we are getting a sine wave. I'm going to turn the HFE up. Yeah. And actually, let me increase my SIGGEN. There we go. 10 by 10 each. And already I can tell that's a much cleaner signal. I'm over here on max. Okay. And I'm not getting that distortion that I see on that signal anymore. So let me turn the volume down, turn the LFE down. Let me hook it up to the speaker and we'll see if it cuts in and out there. Okay, I'm gonna run it one more time now that I have all the bells and whistles tightened down. We're on. Audio, 90 hertz signal. Turn down, put it over in the bypass. A 100 hertz signal. Stress testing it. I didn't mean to jump right there. I mean, you got the volume at max. It's a good sound on the LFE at 100 hertz. Let me put it in the bypass. No, I'm not constantly cutting out anymore, so I think this one's fixed. Definitely appears to be the case. Now here's the deal. When you're running these lower entry like Klipsch SW-450 amps, make sure that you are using a home theater system with a sub pre-out. Okay, Because the pre-out is at a much lower amplitude than a standard subwoofer output. Denon, I think, is like around 1 volt or so. If your receiver output is too high, then you're going to start clipping the audio as it's amplified into here, and that causes these ICs to go bad. Their shelf life just drastically diminishes. So you need to use a pre-out. Secondly, when we are dealing with subwoofers, the amps are designed to be more powerful, if I can put it in those terms, relative terms, than the speaker, like rated for a higher wattage than a speaker, right? And so the intent of that is for you to never have this at max. You don't want to have the volume at max. You want to have a good listening volume. And then somewhere on the LFE, around 80 to 100 is typically where you would put your low pass filter, okay? And then from there you get a good volume somewhere around mid to maybe 3/4, but you never should be just cranking both things all the way up. That's a good way to blow these amps. They're just not, it's by their design, okay? But I'm not getting constant clipping, cutout. So, I mean, I had to, when I was clipping a lot, when I first started doing this, 80 hertz at max, it would constantly cut out even there. So, yeah, I would say that, that this amp is repaired. I'm going to email the customer and let them know that it's working. And yeah, so very similar to when we had no output and it was the amplifier was blown and the IC was blown. If you're having constant cutting in, cut out, check the voltage rails if they're good. Now I went ahead and replaced the caps that tend to go bad in the power supply for this customer. But check the voltage rails if they're good. Move on to your 2 ICs on the board and get those replaced. Now you can check the capacitors and everything on it as well. But it seems like the common failure point for the audio side is both your ICs. So, and my personal belief, and this might not be the case with this current customer, but you really need to understand how these amplifiers work as Class D amplifiers. They're designed to have a pre-out from your home theater receiver. You don't want to have the volume too high because that causes clipping inside the amplifier circuitry, which will destroy the output amplifier IC. And then when it comes to using your LFE and your volume control, you're never supposed to have these things sitting at max on the volume. That's a good way to ruin that DDX IC. They are what they are by the design of this amp. So you want to get it somewhere between 80 and 100. That's typically where you get that good bassy type tone. And then from there, just adjust the volume up from that point until you're at a level where you're like, okay, yeah, I like that. That makes my home theater sound good. So now for people who buy more high-end amplifiers, then obviously you're going to get a lot more sound out of them than this, what, 450 watt, I assume, or 300 watt amplifier, because really there's not much difference between this SW-450 and the 350. There's really not. But there you go. I'm rambling now. If you enjoyed this video, please let me know by giving it a thumbs up. Leave a comment in the comment section. Thank you for watching. As always, take care and goodbye. Bark?